Hello everyone, in this video, let us talk about different types of wiring, wiring maintenance and wiring repairs. For example, when we examine the two terminals of the batteries, one performs like a positive and the other one works as a negative terminal which is recognized as a DC supply. In the AC supply, the current direction is not constant because the current direction is reversed for every cycle. Therefore, for any device's operation, its terminals' polarities must be identified for proper connections. If appropriate connections are not made in a house without experiencing a polarity test, it may end in a short circuit. So, to avoid such situations, we manage a polarity test for every device prior to its operation. To check the polarity in DC, set the multimeter in DC mode with the appropriate range. Place the positive and negative probes between the terminals if the readings show positive. The red and black probes that you placed are positive and negative terminals respectively, which is the correct one. If the reading showed negative, you had reversed the polarity. You have to reverse the polarity. To check the polarity in AC. In AC as in DC, using a multimeter to check polarity is not possible since AC has changing polarity or alternating. You can check whether the wire is connected with phase or neutral using neon tester or test lamp. Circuit should be kept turned on. If the neon tester glows when placed in the conductor, it is a phase conductor. If the lamp doesn't glow, it seems it is a neutral conductor. In the same way, a test lamp is also used to find the phase and neutral terminals by placing it on the terminals. Two lamps with 220 volts are connected in series are used to check the line voltage in three-phase system. Continuity test. The continuity test, as its name suggests, is to test the continuity of the current in wires, fuses, and electronic components. Simply, it is to determine if the current is freely flowing from one end to the other. Continuity is to check how much resistance there is in a closed electrical circuit. This is an important element to check with a multimeter because poor continuity can cause fires, shocks, or damage to the electrical devices. Let us discuss how to proceed a continuity test. Completely remove the wire or fuse from the circuit that has to be checked. Set the multimeter in continuity mode. Generally, the continuity mode will have a sound symbol. Insert the red and black probes into the multimeter at the appropriate portions. Plug the black cord into the slot labeled COM and the red cord into the slot labeled MAV or AV. Touch the metal parts of multimeter probes together to make sure they work. Most multimeters will also beep if the signal is good to indicate that the continuity setting is working properly. If not, check the ports that your terminals are plugged into or replace the probes or check the battery of the multimeter. Place the multimeter probes on both ends of the conductors in the wires. If you hear the beep sound clearly, it seems the conductor in the wire is good. No damage occurs. If no beep sound occurs, it shows there is damage or discontinuity in the wires. Replace the wire with a good one. Maintenance of electrical wiring. Our daily lives depend heavily on the electrical system, which must be kept in excellent working order for both the safety of the occupants and the structural integrity of the house. A qualified electrician must fix damaged electrical wires since they can be dangerous. If they exhibit any signs of dysfunction, they should be changed as soon as possible to avoid any risks. A well-maintained electrical system lasts longer and gives you peace of mind that your home is safe. Routine check. Similar to personal health, keeping an eye on your electrical system on a regular basis is important. You can inspect your wiring and power outlets on a regular basis on your own. A good check on your electrical system twice a year can help you acknowledge a potential problem before it's too late. The earlier the issue is taken, the easier it gets to resolve the problem and avoid risks due to failure. Water and electricity should not be combined. Even though this seems like common sense, electric shocks can happen at home. The cause can be the washing or wiping of household appliances. Use only high quality material. Given the possibilities on the market today, it is a natural human tendency to be drawn to low cost goods. However, using the same thinking to wire outlets can be dangerous and life threatening, and therefore cannot be a situation where one should act economically. The best option is to choose approved parts and equipment. In order to keep yourself safe and extend the life of the electrical system, make sure that the replacement goods are certified. Do not overload. One of the most typical issues with household electrical systems is overloading. It's important to know how much electricity your appliances use and how much power your outlet offers, because doing so can prevent accidents. Kitchen appliances should have their own plugs because they use a lot of electricity. A power outage might result from overloading a circuit with many plugs. Each circuit board has a specific limit to the load it can take, but within that limit, the appliances connected to it should function perfectly. A sub-circuit loads should not exceed 800 watts as per the Indian standards. Also keep an eye on open wire in the attic being nibbled by rats or raccoons or rainwater pooling around the circuits in the basement. Even though the impact might not be felt right away, any wire damage might pose a major risk. Repairing of electrical wiring. The outer jacket of electrical cables can usually tear when they are moved around and bent repeatedly, exposing the wires inside. This is especially prevalent in cables that are used regularly, like as phone and laptop chargers. If you notice any exposed wires in your electrical lines, you should patch them right away to stop the issue from getting worse. Use electrical tape to repair minor damage to any kind of electrical cable, heat shrink tubing to repair more significant damage. It is usually better to replace a cable if its electrical wires are severely burnt out and the outer jacket of the cable keeps tearing, exposing the wires. Select heat shrink tubing with a 2:1 ratio and a diameter twice that of your cable. Cut the heat shrink tubing to at least twice as long as the damaged area. Slide the heat shrink tubing over the damaged area. Use a heat gun or hairdryer to heat the tubing until it shrinks. From this video session, I hope you can do conduit wiring, casing and capping wiring, testing, repair and maintenance of wiring. Thank you for watching. Have a good day.